query. That means how the DQL statement is processed, right? Yeah, DQL statement is processed. The first step wise phase is like parsing phase. Okay. The second one is the execution, and the third one is fetch. This is common for every, okay, every process. This is the common one. Today we will look into DML statements. Okay, how and DML DML I will go for update. Okay, update statement. Update statement is going to process in. So let's begin this DML. Uh, ABC. Okay, so this is where our instance is looks like. So yesterday, as I said, the starting of the process is like the parse phase, okay, and the second is like execution phase, and third is like fetch. That means retrieving the data. Okay, so here, whenever a user raise a request, whenever a user raise a request, on behalf of database side, that user request will be handled by server process. Okay, handled by the server process, and for each user request, one server process will allocate, and one PZA private memory area will be allocated, and for that particular statement, okay, what are the statement this user is trying to executing, okay, for that one hash value will be generated. Okay, based on the hash value, this parsing activity will depends. So today we'll see like update process, like the user is trying to using a DML operation called update emp set emp salary, okay, equal to 1000, okay, emp id equal to 5. So the employee id with 5, who is the employee id with 5, his salary is going to be updated 5000. Okay, like employee id 5 salary is going to update from 1000 to 5000. Okay, 1000 is the old value and 5000 is the newest value. Okay, that is yeah, newest value. So as per the regular process, what will happen? This request, okay, this request will come into picture, and from database end, the server process will be allocated for this particular user or user request, and one private global area or program global area is allocated along with for this query a hash value will be generated. Hash value, how it will be like hash value, it will be in the digits, okay, hexadecimal value. What's it? It's a hexadecimal value. Okay, so these hexadecimal values will be stored in this SQL element after parsing. So if we have a parsing of two kinds, like hard parsing and soft parsing. If this is the statement is executing for the first time, okay, for the first time, it will generate this hash value, and this hash value will be looking into the SQL element, whether in order to know whether it is a hard parse or soft parse. Okay, if the hash value is not, why? Because for every statement there is a dedicated hash value will be allocated. The hash value won't change if the statement is executed for the first time or the statement is executed for n number of times. The hash value which is generated won't be changed. Okay, so here the hash value, first it will, the server process will look into this SQL area about this hash value which was generated at the same time, okay, whenever a request comes, the server process PZA and hash value all together will come into picture for that to handle that particular request. So it will look into this SQL area whether this hash value is present or not. If it is not present, then it will go for hard pass. Okay. If it not present, if it is not present, it will go for hard pass. What it will do in the hard pass? Hard pass. If it is present in this SQL area, then it will consider as soft pass. Okay, soft pass. Okay, so if it is a hard pass, what will happens when it is hard pass? First, it will go for the validations. Okay, first it will go for the validations. What are the validations? We have three types of validations. One is syntactical, second one is the uh, semantic check, and third one is the privilege check. Okay, so in this phase, if the update statement is not executed at all, then it will check for the syntax whether the query syntax is correct or not. Yesterday I have shown you how the syntax will be validated, and again the second check, if syntactical check is passed, then it will move to second check, it's semantic check. The semantic check will go and fetch the details from the data dictionary where our database objects are present. Okay, it will check whether this table is present or not. If it is present, then it will move to the third check, is the privilege check. Whether this user who is trying to execute this statement has privileges on this table for accessing or not, it will check. If all the checks are passed, then it will go for library cache, then it will go for library cache, and where a optimizer will come into picture. Optimizer will come into picture. Okay, what optimizer will do? For this particular statement, it will generate an n number of execution plans and it will calculate those plans and it will pick the best execution plan for this output, for this query, to get the result uh, in an accurate manner. Okay, those all operations will be done by this optimizer automatically. This is a piece of software in our instance. Okay, once the optimizer is generated an execution plan, then the execution will start. Okay, then that statement will go into the database buffer cache. If the data is present in the database buffer cache, well and good, it will return it back to the user. If it is not present, then what it will do? It will collect from the data file. It will collect from the physical files, right? From here, it will collect and it will keep. Who will do this process means server process. Server process will collect this data from the database, and it will put it into the database buffer cache, and the process will happen. And once the process will happen, again, who will retrieve that information and who will give to the client process means the same server process. Okay, again, once the data is completely here, server process will take it and it will give it back to the user. This is the process how it goes. Today, the update process, how the update process is going to happen. Okay, so same thing, the hard the parsing, execution, and fetching, everything is completed. All checks are passed, and it will move to the database buffer cache, where our exact update operation is going to happen. At this point, okay, at this point, here the old value of the user is 1000. Okay, it- here, as I said, the server process will come to the data files, that is our physical files, and it will collect the value 1000 and place it over into the buffer, that means our database buffer cache memory. Okay, here the 1000 value, old value is kept. So once this particular block is going to update, there will be a lock will happen. Okay, this block will be locked. That means no other users can access this block. Okay, this will be locked with the old value, and it is updating, and it will start the upgradation process of this value from 1000 to 5000, 1000 to 5000. But this is locked, right? Even if it is locked also, the users can access it for read only purpose, not read write. Okay, no, if it is locked, if any of the block is locked with the database buffer cache, then no users will do the read write operations. Only read operation can do. But if if a user tries and try to read this block, okay, still that user will get the old value 1000 itself. Why? Because it is logged at old value. It is logged at old value. So the other users who are trying to read this particular block will get the old value. Okay, so leave it like that. And here, once the updations are happening, okay, updations are happening. What are the changes is happening? Those changes will be reflected into the redo log buffer cache. That means, for suppose 5 is the employee ID and his salary is 1000 earlier, the old value. Now it is going to change it to 5000. See, redo log buffer cache is a memory area where it will capture all the changes happening in the database buffer cache for, for making the database consistency level and recovery purpose. Okay, the value is 5, the employee ID is 5, old value is 1000, and new value is 5000. Okay, so in parallel it will write it down, but the old value, which is 1000, also will be stored in this table space. Undo table space. What is this undo area? This undo area is a place where all the old results will be stored until a commit happens. Okay. Undo area. And undo area is nothing but place where our old values are going to store temporarily. Why I said temporarily means, that means until a commit occurs, the old value will be stored here. For the old value, I don't know whether you guys are capturing this one or not. 1 second. The old value 1000 will be stored here until a commit happens. Okay. In general, see, here only I will show you how the undo is there. See now what I have written, right? Okay, these are the current changes. Okay, but the old value, that means this 1000 I didn't return. Okay, here this is empty place. If I want to remove this one and get the old value, that is the empty space. In general, in our uh, regular way, we'll do what we'll do control Z. Control Z means we'll get the old value. How? Control Z means undo. He's doing undo. That means it is uh, retrieving back the old values. Okay, see, before that I have updated with a line like 1000, but I didn't want this one. Okay, but I didn't want this one. I want to get the old value. That means empty space in this case. Okay, so I'm just simply giving Control G. Then it is getting the empty. The same way in Oracle instance also, the old values which are modifying in the, I mean, which is modifying the database buffer cache, those old values will be stored in the undo area. If in case the user is change his mind and want to get the old value, then from this undo space, it will roll back the value. Okay. But that is also there is a condition. If the user doesn't commit, then only this undo value can be rolled back. If user committed, if your user is committed the value 5000, then it will be, then in this undo, this value will be gone and he can't roll back the old value. He can't roll back the old value. Why? Because already 5000 is committed. The transaction is saved. Okay. This is how the undo process will do. Okay. And see here, whenever a user is trying to update the update a value, is updated, is committed, but these changes won't write immediately into data files. That means our database. Okay, physical database. Here, these values, then who will write these values to the data file means this DB writer. Okay, DB writer is a background process which is dedicatedly supports the database buffer cache to write to write down all the modifications or all these committed transactions into physical data files. Who will write this DB writer? But whenever a user makes a commit, okay, immediately those commits won't write by the DB writer to data file. Okay, DB writer has its own conditions. So on those own conditions, it will execute. What are those own conditions? Like whenever a, whenever a buffer cache is filled, then DB writer will invoke and it will write all the changes to permanent to make it permanent and erase those values from the memory and make it some free space. And whenever a checkpoint occurs, liberator will write all the committed transactions from this memory to yes. Okay, this is how the update process will going to happen. Okay, and this is how update processes happen in parallel. Okay, in parallel this redo log buffer cache will also processed with all the changes. So what are the changes is happening? If it is a rollback also the 1000 value, then again it this redo log buffer will capture those changes and it will write those changes to online log files. Online log files are the physical files for redo log buffer cache, and log writer is the background process who will perform to write those changes into physical files. Okay, log writer. And log writer also will work on certain conditions like whenever a user committed this data, then from log buffer to log file, this log writer will write. And also whenever this log buffer is filled one by third, then log writer will invoke and write the data to online log files. And one more condition is like When it reached 1 MB of space, when redo log buffer cache reaches 1 MB of space, then log writer will come into picture and it will write. Okay. So this is how log writer background process will work. This background process is dedicatedly for redo log buffer cache, and it will do the operations behalf of redo log buffer cache. When the checkpoint will occur, checkpoint is a background process, okay, where it will for every transaction, so we have a system change number, SCN. Okay, SCN means system change number. SCN, system change number. System change number. That means what are the transactions are happening, for that one a dedicated number will be created in this Oracle. In this Oracle database, a system change number. It is identified with a system change number. That is simple. Okay. That's simple. With system change number, the transaction is marked so that the identification is very easy. So what it will do, it will whenever a log file, I said for redo log files we have minimum two online log files. Okay, two online log files. There is a one more log file. Okay, online log file. Okay, so once this file is filled, a log switch occur and it will start writing the second log file. At that time this checkpoint will come into picture, and what are the files are written already. Okay, those SCNs will be there, right? For each transaction, each SCN will be there. Those SCNs will update in the physical data file header and control file headers, and it it signals the DB writer that these SCNs are already updated. So what DB writer will do? Then DB writer will write the information from this buffer cache. Okay, this buffer cache to data files. This is how this check pointer will go into process. Okay, that's why if you remember, okay, DB writer will invoke on certain conditions. Okay, what are those conditions? Whenever a checkpoint occurs, DB writer will write the data from database buffer cache to physical data files, and DB writer will write whenever a dirty block is filled, or whenever in database buffer cache there is no space, then this will file, or whenever a table space is kept in offline mode, then also the data will be written into DB writer. On these conditions, DB writer will invoke. Okay, this log writer will invoke on this 1 by third if the read log buffer cache reaches 1 by third, or it filled for 1 MB. Okay, or whenever a commit happens, this log writer will invoke. And checkpoint, I said, whenever a log switch occurs, this checkpoint will occur and write the all the system change numbers. All the system change numbers will be updated into the data file and control file headers. Okay, and also it signals the DB writer to write the changes from database buffer cache to data file. This is how an update process. That means a DML process is going to processed in the instance. Okay, and DML is processed in the way. What about the DDL? What are the statements in DDL? In DDL we have create, alter, drop are the statements, right? Create, alter, drop statements. Okay. Whenever a user is trying to create a table, or whenever a user is trying to alter an table, okay, whenever a user is trying to drop a table from the database, what it will happen means when our client is trying to make some DDLs, the same phase first is first phase is parsing, second is execution, okay, third one is here there is no fetch actually, okay, here only update, so update phase, okay, what it will happen, these three phases it will pass, and here for DDLs it won't go for the library cache. Why? Because all the DDL operations will be hitting this data dictionary. Why data dictionary? In this data dictionary all the database object level information is stored. Okay, all the data dictionary or sorry data object information is stored. What are the database objects means? Tables, views, and synonyms, procedures, whatever. Okay, so this server process will look into the data dictionary cache and it will update the data dictionary cache. Okay, so if it is a create statement, it will create a new table, and that table information is stored in this dictionary. If this user is trying to creating a new user, okay, then that information will be stored here. If he is trying to modify a table, that means alter, then that information also will be stored here in data dictionary memory. Okay, if you want to drop a table, that information also will be updated in this data dictionary. So all the DDLs will directly hit the data dictionary memory itself only. No other, no library cache, no database buffer cache, okay, no readable buffer cache. It simply hits the data dictionary cache and it will works inside this data dictionary. For data dictionary cache, what is the physical data file? Means system data file. System data file. This will cover in our database concepts. Okay, just for time being, you just remember like system data file or system table space. This is the physical file for data dictionary memory. Okay, so what are the things happening in physically? This system table space will be impacted. Okay, if he is creating, that information will be stored here. If he is altering, that information will be stored here in this system physically. If he is dropping from this system table space, that particular object will be removed and updated in this data dictionary. That is how DDL will process. Okay, so this is about DML and DDL operations, how they are processing in the instance. Okay, that's all guys for today.